All right, ladies and gentlemen, today we're going to look at the idea of irrational square roots. If you remember, we've spent a lot of time yesterday talking about rational square roots. And when we looked at those, we knew that we could use page 681 if we needed to, and they were all perfect squares. But today we're going to look at this idea of irrational numbers. And if you look here, this prefix ir means not. So these are going to be numbers that are not rational. And we're going to see that for us, the best example of a number that is not a rational number is pi. Remember last year when we did when we had Pi Day, and we actually had somebody memorize pi to 103 decimal places? Because it doesn't terminate, it doesn't repeat, there's no pattern, it goes on and on and on forever and ever, amen. Now, so we know pi's an irrational number. We spent some time looking at that last year. But for us now in Algebra 1, a number that's going to be an irrational number is a number inside the radical, a number that's inside the square root sign that is not a perfect square. Now, if you went and you punched in the square root of 2 in your calculator, it would say 1 point, and then it would give you as many decimal places as your calculator will allow. It keeps going on and on forever, amen. If you notice in the back of your book, we have another chart that has all the square roots, and they actually round it to 3 decimal places. But for our purposes in Algebra 1, we're just going to look at this idea of these irrational numbers as we go through. So let's look up here and let's see if we can put these square roots in the right place, whether they're rational. Rational means I can write it as a fraction. It means it can be a decimal that terminates or repeats. If it's irrational, remember then it's not a perfect square that's inside the radical or goes on and on forever. So let's look here. If I had the square root of 32, is that rational or is that irrational? Well, 32 is not a perfect square, so the square root of 32 would be irrational. Let's look at this number 2.8. Can a rational number be a decimal? Yes, it can. We spent some time on that. Can it be a repeating decimal? Yes, it can. So 2.8 is going to go over here under the rational side. Well, as soon as you see pi with the 5 pi, anything pi is going to be irrational. Let's see. Look at this next number. We've got 7.32105 ... What do you think that ... means? Yep, on and on forever and ever, amen. If you notice, it doesn't terminate. There's no repeating pattern. Because of that ... going on forever and ever, amen, it's irrational. Now, if we look here, 256 is actually a perfect square if you look it up in our table on page 681. And then when I get to 0.35, again, that's a decimal and it terminates. So therefore, it is a rational number. So with this in mind then, who can raise their hand and tell me another irrational number that's in a square root? Right, the square root of 11. 11 is not a perfect square, so that is an irrational number. That's right, the square root of 7 is an irrational number because 7 is not a perfect square. So, since that's the case, we've got to be able to use the product property of square roots to simplify radicals when the radicand has a perfect square factor. So what we're going to do is we're going to look at this idea, square root of 50. Now, if I look up the square root of 50, it's not a perfect square. So I need to come up with 2 numbers, 2 factors of 50, but one of those factors has to be a perfect square. Well, some of you are going to say right away 5 times 10. Well, there's a problem with that because neither one of those numbers is a perfect square, so it doesn't help me. That's it. Okay, I need to say the square root of 25 times 2. Now, 25 is my perfect square. The square root of 25 is 5, so it's going to come out of the house, and the square root of 2 stays in the house. So once we come up with our 2 factors that when I multiply them together give me the radicand inside, we take the perfect square's square root and put it outside the radical, and then the 2 stays inside. Now, let's look here at our next problem. Did you notice I got a number outside the house here, a 3, and then we've got 216. Now, here's where those divisibility rules are going to come in handy. All right, now, I would agree that that 216 is divisible by 2. Would you agree that it's divisible by 3 as well? Yep, if we add those numbers up, we get 9. But if it's divisible by 2 and it's divisible by 3, then it's also divisible by 6. That's right, good job. So we could make this be the 3 on the outside, and then this is actually 36 times 6. Okay, so who's my perfect square? My perfect square is 36. The square root of 36 is 6. Now we're going to take that and multiply it by the number out in front. 3 times 6 is 18, and then square root of 6 on the outside. Okay, so if there's a number out in front of our radical, when we pull out our perfect square, the square root of our perfect square, we got to multiply it by the number that's out in front. Let's try a few more and see what happens. Okay, let's look here. If I have, on number 1, we've got the square root of 28. Can you think of two numbers that with two factors and one of them is a perfect square? That works. We've got 4 times 7. 4 is my perfect square. The square root of 4 is 2, and then root 7. If you're looking at number 2, what two numbers? Now, 12 times 10 is not going to help me. Neither one of those is a perfect square. There it is. Okay, so we're going to say 4 times 30. Okay, the square root of 4 is 2. Now, can I simplify 30? Well, if you think about it, 1 and 30, that's not going to help me. 2 and 15, 3 and 10. So square root of 30, that's in simplest form. All right, now let's look at number 3. Show you a couple shortcuts. 2 factors of 108. 2 factors of 108. Well, when I look there, okay, it's divisible by 2. It's also divisible by 3. If it's divisible by 2 and 3, then it's also divisible by 6. So we're going to have this. And then, here's what I put. I said 36 times 3. 36 times 3. Okay, so the square root of 36 is 6. 6 times the 6 that's already out in front, we got 36 root 3. Okay. Now, little hint here. Some kids might have said, oh, Mrs. Burton, 108 is what? 12 times 9. So if you did 12 times 9, well, 9's a perfect square. Did you realize we can actually simplify 12 as well? 12 can become 3 times 4 times 9. Okay, square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. And then 6 times 6, that gives me 6. 6 times that 6 is still 36. So a couple different ways to get there. Every once in a while they throw a number in like number 4, and hopefully you would realize that that's a perfect square, and the answer is 18. Okay, square root of 324 is 18. Now, let's do a few harder ones before we're finished. Everybody look at number 5. Well, I know that 75 is not a perfect square, so we've got 14, but I know that 25 times 3, the square root of 25 is 5. 5 times that 14 out in front, and that would give me 70 root 3. Now, number 6 was my problem child. It took me forever to figure it out. I was brain dead. I couldn't think of any numbers that worked. So guess what I did? I caked it. Remember how to use cake? If we did 684, remember when we're using our cake, we take the smallest prime number, and 2 goes into 684, 432. Well, 2 will go into that as well, and that gives me 216. And remember, I keep using 2 until it won't work anymore. 2 goes into 216, 108. Well, that's an even number. 2 will go into that, 54. 2 will go into 54, 27. Now, 2 will not go into 27, so the next prime number is 3. 9. 3 goes into 9, 3. And you got to keep trucking until you get a 1 at the end. Now, remember when we did these before, since I'm doing square roots, I'm looking for pairs of numbers. I got 2 2s there. I got 2 2s there. That guy doesn't have a partner. I got 2 3s, and that doesn't have a partner. So we're going to multiply the pairs. 2 times 2 is 4, times 3 is 12, and then the guys that were left over get multiplied together and go in the house. All right, so final answer on this one then is 12 root 6. If we look at number 7, well, when I look at number 7, I know that 3 goes into there, so I'm going to make this 3 times 121. 121 is my perfect square. The square root of 121 is 11. 11 times 4 is 44 root 3. And then number 8. Well, let's see. What do you think we got? Well, you could say 92 times 100, because that would work. So then we would have 10 root 92. Now, how are we going to divide 92? 2 goes in there, but 4 also goes in there. This is actually 4 times 23. So we get 20 square root of 23. Okay, so if my number inside the radical is not a perfect square, we're going to classify it as an irrational number, and we can take irrational numbers and we can simplify them.